So two molecules that you should know the common names for are these two molecules here, okay? One on the left is toluene. It's definitely not used as commonly, but basically it's benzene with a methyl group, okay? The other one is phenol, okay? Similar to phenyl, except this one is called phenol. Why it's called phenol? Well, it ends with the "ol." Usually, when something ends with "ol," that means it's an alcohol. And oh, look, here we go. We have an alcohol right here. Okay, and then phen, if you think about what benzene is sometimes it's called a phenyl, right? So when it's called a phenyl, that means it's a side chain. In this case, it's a phenol, which means it's an alcohol. So anytime you see phenol as a name, that implies that you have a benzene where that OH is on carbon number 1, okay? It's always on carbon number 1. So like if I told you a 3-methylphenol, you would start by drawing phenol, which is this, benzene with that OH, and then 3-methyl, you'd be like, okay, well, if this is 1, 2, 3, or you could potentially go 1, 2, 3, and then over here, you'd be drawing a methyl group, okay? So next type of functional group is what we call an alkyl halide. This is still an organic derivative because it has some stuff in it that's not just C and H. So still hydrocarbon, but now they're going to have a halogen, right? So if you think about what our halogens are, they are chlorine, they are bromine, they're iodine, and they're fluorine, okay? So alkyl halides are, for the most part, all going to be artificial. They're things that we create so that we can use them generally in the production of pharmaceuticals, right? That's where most of our organic molecules do get used, is for pharmaceutical or medical purposes. Okay, so when it comes to naming these guys, same thing as always. We have a prefix, we have a root, we have a suffix. So your root is going to be the longest chain of carbon atoms that have that halogen attached to one of them. Okay, so start by doing that, figuring out how many you have. So your prefix, just like always, you're going to number the parent chain. So for the most part, you're still following the same rules. You want a number so that you get the lowest possible number. Okay, so if I start numbering from the left side and something's at 2, and I number from the right side, something's not till 4, a 2 is smaller than a 4. So we are going to follow that order, okay? If we have a tie, so now that we start talking about alkyl halides, our order of priority is going to change a little bit, okay? So alcohols, we already said, were the most important. Then it was our alkynes, then it was our alkenes. We're going to find that our halogens basically go in alphabetical order alongside our alkyl side chains, okay? So they are pretty low on the priority chain. So when we go to actually place them into the prefix, they're called chloro, fluoro, bromo, iodo. They all end with that O at the end of it. If there's 2 of something, like 2 chlorines, we would say dichloro. If there's 3 of something, we would say tri of that. Again, if there's more than one thing that needs to go into the prefix, you are going to put them in alphabetical order. Okay, so 2 examples here for you. So we're still following the same general process that we normally do. We want to start by figuring out where that longest chain is in this whole thing. So here, if we start at this one, and obviously because we have a bit of a line diagram, we have a bit of a curvy chain. So that's our longest chain. It has 1, 2, 3, 4, 5, 6 carbons in it. So next step, determining where we number from. So 1, 2, 3. So first thing is out of 3. 1, 2. First thing is out of 2. So because a 2 is less than a 3, we are going to number starting over here. Oh, okay, that was supposed to be a 4. That was not a 4. There's a 4. So 1, 2, 3, 4, 5, 6. So process that we're following. we're looking at this. This is an alkane as my parent, right? And the reason I'm saying it's an alkane is everything is a single bond. So things that need to go in it. When we look at what's sticking out of it, we just have some halogens. We don't have anything else. So those are the only things that need to go into our prefix, right? We have a chloro over here, and we have 2 bromos over here. So alphabetically, bromine comes before chlorine. So we are going to have a 2,4 dash dibromo, right? Di, because there's 2 of them, bromo because it's bromine, then dash 3 dash chloro. Then we go into our root, which is going to be hex, and then ene. All right, so now we look at our other example over here. So this one is a little bit different, and the reason it's a little bit different is we have a cyclic compound. So this isn't benzene, and the reason it's not benzene, there's no circle in the middle, there's no alternating single double bonds. This is just a cyclohexane, okay? So when it comes to a compound that's cyclic, when we think about our cyclic rules, we said that we get to pick where the 1 is going to go to. So alphabetically, the bromine comes before the methyl, which is why we are going to choose to start numbering with that bromine. Okay, sorry, I got rid of that 1. I don't know why it was there. So 1 can either go to either of these bromines. We're actually going to choose this bromine. And the reason we're going to choose this bromine is if I choose this one as 1, then I'm going to use a 3 and a 4. If I chose this as 1, I would use a 1, a 2, and a 5. Because a 1, a 3, and a 4 is less. Those are going to be the numbers that we are going to want to pick, okay? So prefix-wise, there's 2 bromines to go in it, so dibromo, and then there's this methyl. Again, we're using alphabetical order, just like we always do, so that bromine is going to come first. So we're going to have 1, 3, dash dibromo, then dash 4 dash methyl. And because this is cyclic, we're going to go cyclohexane. Okay. So you can see how when we start getting into these alkyl halides, they kind of start to be a mix of things, right? It could be an alkyl halide that's on an alkane, like our first example. Could be an alkyl halide that's on something cyclic, like our second example. And when you look at some of the questions that are in your work booklet, you'll see that there are other options as well, right? It could be on a benzene. It could also be with an alcohol. There's a lot of different things that you can get. But for the most part, you're going to find that like quiz, test-wise, we're usually going to cap out at like 2 different things happening. So I know a lot of you guys, especially with organic, you come up with these crazy molecules that you worry about that are like insane, that like have all these ties and all these things going everywhere. We're never going to give you a question like that. So I wouldn't worry about seeing a question like that.